Suppose you're interested in evaluating the integral of tangent to power 5 of x times secant to power 7 of x dx. So let's go back to pre-calculus, see what we remember from pre-calculus. From pre-calculus, we know that if we have tangent squared, it can be written as secant squared of x minus 1. Okay, how this is useful to me? Let's see if we can break this guy down into smaller pieces. Let me try to write tangent to the 5th as tangent to the 4th of x times tangent of x. So I just broke this guy down into 2 pieces. And for the secant, I can write it as secant to power 6 times secant. So I'm just slowly breaking these guys down into smaller pieces so I can find a relation. And then dx. So this is my secant. Very good. So what do we have here? Tangent squared is secant squared minus 1. So tangent to the 4th of x is equal to secant squared of x minus 1 to the 2nd power. Okay. If I write it this way, what do we get? We get the integral of secant squared of x minus 1 to the 2nd, which is this guy here, times tangent of x times secant to the 6th of x times secant of x dx. What if I take u to be secant? So by using u substitution, if I take u to be secant of x, secant is 1 over cosine of x. How do you calculate du? du is equal to the derivative of 1 is 0 times cosine minus the derivative of cosine, which is negative sine. So negative, negative, you get sine x divided by cosine squared of x dx, or du, as you remember, is secant x times tangent x dx. Do I have it? Yes, I can see just right here. This is my du. So this integral can be written as the integral of my u squared minus 1 to the 2nd u to power 6 du. So u squared times u to power 6 times du. Now we are going back to calculus. From calculus, the integral of u to power n du is u to power n plus 1 over n plus 1 plus constant of integration. Well, we can simplify this guy further. This can be written as the integral of u to power 4 minus 2u squared plus 1. Then you have u to the power 6 that you can distribute times du. So distribute this guy into parentheses and then simplify as much as you can. So you get the integral of u to power 10 minus 2u to power 8 plus u to power 6. Then we have a du next to it, which in turns can be written as u to power 11 over 11 minus 2u to power 9 over 9 plus u to power 7 divided by 7 plus constant of integration. But again, what was u? U is secant of x. You have to substitute this guy back here. So you get secant to power 11 of x divided by 11 minus 2 secant to power 9 of x divided by 9 plus secant to power 7 of x divided by 7 plus constant of integration. This is our final answer.